Welcome, everybody. Can you advance to the next slide, Roger? Thank you. First, we'd like to thank everybody for attending the webinar series and the Big Data webinar as the first in that series. We want to go through a couple of logistical things before we get started. So everybody in the webinar will be muted throughout the presentation. Please use the Q&A feature to ask questions. I will be monitoring the questions and bring them up to Roger when it's appropriate. Also, we're going to use the chat feature to post any comments. Now, we do want to clarify that this webinar is open to Nimble members as well as non-Nimble members. So if you're a Nimble member, please remember to keep Nimble confidentiality and proprietary information confidential and not put it in the Q&A or the chat feature. Also, after the webinar, there will be a short survey sent out to gather some information and feedback from all the attendees. And once you complete the survey, you will have immediate access to this recording. So the survey will be sent out following the webinar. Okay, so at this time, well, actually, there's one more thing. There's a closed captioning feature at the lower left-hand corner if needed. So at this time, I'd like to introduce Roger Hart. He's a Nimble Senior Fellow. He has 30 years of biopharmaceutical experience, and prior to Nimble, he was the Scientific Director of Process Development at Amgen. At Amgen, Roger had a lot of years experience working on collaborations with universities, consortia, external stakeholders. So without further ado, here's Roger to start the seminar.
Thank you, Jim, for that introduction. I'm delighted to be here. Thank you all for attending, giving me an opportunity to be able to share with you the Big Data program conducted with the Nimble Consortia. The Big Data program has its origins with the Technical Activities Committee, and it's prioritizing this topic, among others, in early 2019. And embarking on the journey by holding a workshop at the 2019 national meeting in Washington, which was attended by about 130 attendees that worked through a variety of opportunities and ultimately endorsed creation of additional workshops in order to develop the program. And that was followed then by 2 different in-person workshops that were hosted by NC State University, attended by 50 or more people in September and November of 2019. And those workshops were attended by people from large companies, small companies, academics, biotechnology industry, as well as government and select experts. It was really quite an exciting time to be able to talk about the particular opportunities and needs associated with data in biotechnology. And out of that workshops, we defined work streams in order to advance initiatives within big data. And then in the very beginnings of the COVID lockdown, we transformed from in-person workshops to virtual workshops in order to develop objectives and plans for a 2-year time frame. We utilized virtual rooms where hosts and scribes and leads were held in one room. And all the different participants, again, about 70 participants from, again, the whole spectrum from large companies, small companies, academic, government, were in attendance. And they were rotating between all the different workstream rooms in order to develop the best understanding of objectives and plans for a 2-year time frame in order to advance big data for biomanufacturing. Having established that plan, the Nimble Consortia endorsed and embarked on the Big Data program with the overall objectives to facilitate data exchange and transfer among all the different participants in the biomanufacturing ecosystem, to develop and demonstrate adaptive control for critical quality attributes using advanced analytics, including multivariate sensors, and to use advanced process models to improve process understanding, enable speed, and enable control. In order to advance those initiatives, 5 different work streams have been formed, and in those work streams, the leadership, the leaders for each work stream come from the different nimble industry members that are participating to ensure that the projects that are embarked on are value additive for all of the members and are aligned well with the overall missions and strategies for industry for biomanufacturing. The first of these work streams is associated with standardization and contextualization of data, again, across the full ecosystem, from suppliers of raw materials to end users, as well as the process, equipment, and all of the other activities associated with the production in biomanufacturing. Second work stream is for the real-time control of critical quality attributes. And it's focused on, again, demonstrating real-time control utilizing a industrial appropriate platform consisting of bioreactor, depth filter, and protein A as a process artifact and testing adaptive process control with advanced analytics for real-time control. The third work stream is focused on advanced multivariate sensors and analytics, which provide the opportunity for real-time data, again, to support real-time control, but also to use these multivariate analytics in order to extract deep understanding and multiple attributes in real time through the complex signals originating from multivariate sensors, and to develop appropriate data analytics approaches in order to extract the meaning of different attributes from these complex signals. The BD4 work stream is focused on creating data, generation of data to support the other work streams, utilizing high throughput approaches, notably AMBER and TCAN approaches, in order to create data in support of both the Big Data 2 and the Big Data 5 work stream, which is focused on creating advanced models for predictive capabilities for upstream processing and purification. And these models are state-of-the-art and incorporate physics-based principles as well as machine learning in order to expand the applicability of all of the models. NIMBLE considers the Big Data program to be an enabling program to support program not just for the needs of the entire biopharmaceutical manufacturing community, but it's also modality agnostic. So it's applicable across many different programs that occur within NIMBLE, and that the tools that we're developing have extensive applicability throughout the ecosystem. As I mentioned before, the programs or the work streams really do overlap in a variety of different ways, as I think you can imagine. As one creates data, one needs to store the data in an appropriate and contextual form to be able to extract that data in real time to enable control, but also to extract that data in order to develop and train and test advanced models. Similarly, the data that's created is monitored by advanced multivariate sensors, which again needs to be transformed with advanced models to extract meaning, and the resulting data signals need to be stored appropriately in a contextualized database. And when all of this is done well, you can affect the real world through changes with critical quality attribute and process control by utilizing all of the different work streams capabilities in concert. And that's really the synergistic intention for compounding many of the benefits associated with the individual work streams in order to create a more powerful whole, as illustrated by this diagram, wherein creation of appropriate contextualization for data within BD1 becomes the platform to store the data that's created within the high throughput approaches that are implemented. And then the data can be extracted from those registries to develop the advanced mechanistic models, which when combined with the advanced analytics for real time, provide opportunity to both train the advanced adaptive control algorithms as well as to support their maturation and continual evolution. So that there's opportunities for these work streams to work together cohesively in order to enable more significant change. In general, I think you can see also from the structure of the work streams that they're intentionally designed in order to follow the life cycle of the data. In general, data has an origin. It's created at some point, and it needs to be transformed in some way in order to associate meaning with the data, in order to then appropriately store the data in association with the meaning so that it can be extracted at a later time to be able to support predictions with models or also control elements in the real world. So the holistic design of the work streams provide this opportunity to be able to follow the data of the life cycle, but also in order to support the maturation of the data so that the data doesn't start as isolated concepts, but that it continues to grow as we add meaning to it through its contextualization and analysis with models to increase our understanding of data, to transform it into information and then ultimately knowledge. And the overall structure and life cycle is very consistent with the knowledge management life cycle that I'm sure everyone is familiar with, wherein knowledge is people-oriented in terms of sharing and learning in order to identify and create new data, which needs to be managed. And as the information is managed and captured, acquired, and organized, it can then be used for applications wherein it's retrieved and delivered to users, which provides opportunities for discovery and identification of new uses and new applications. And so that's really our intention as well, through having a holistic environment to be able to encourage the self-reinforcement for the growth of data to information and knowledge. Utilizing that overall architecture for the work streams and data in its life cycle, you can see that the BD4 rich data generation work stream aligns itself very well with the data creation. And it has as its objectives to create rich data sets using high throughput technology, as well as privacy preserving approaches in order to collect and compound data from many, many different sources. The 2022 goals have been focused on creating that data within the community, utilizing the high throughput platforms, including, for instance, the AMBER and TCAN and other unified high throughput platforms with advanced analytics that are present both within the Nimble laboratories as well as within the Nimble community and our suppliers and our government partners in order to develop cell lines and media for process development and creation of appropriate process architectures to demonstrate adaptive control and the like. Jim. I'm sorry, Jim, I can't hear you.
Sorry about that. We have a question in the Q&A. Can you comment on the relationship between platform agnostic data collection and the use between big data and the programs that are focused on technical platforms such as process intensification and viral vectors, vaccines?
Oh, that's a great question. Thank you very much. So there's quite a bit of interest within both the process intensification as well as the vectors program in order to utilize different technologies that we're advancing within big data, notably the ontologies for data structuring and storaging, which I'll get to in a little bit. But there's also opportunities in terms of collaborating with multivariate analytics, real-time analytics, which clearly have value with both vectors and process intensification. in developing advanced data analytics approaches in order to extract meaning. So yes, we do seek to realize value from the synergies associated with the big data program to support other platforms within Nimble. Thank you for that wonderful question. So as we move into 2023, we have additional goals now, which really are focused on both maturing our capabilities with our high throughput platforms, but also to really exploit the value of the data that exists within the community at large presently, and to develop, for instance, privacy preserving collaborative computing approaches, which both ensure the security and safety of all participants' data, but also through appropriate contextualization approaches, provides compounding to be able to enhance knowledge and learning, especially within the context of machine learning. So we're working on a variety of different approaches, ranging from federated computing and differential privacy through homomorphic encryption, in order to develop mechanisms for the community to safely share data, in order to develop advanced models and enhance knowledge from this really rich data set that's available within the community. Our second work stream, the BD3 work stream, is really focused on data transformation, because the raw data signal that originates within Creata needs to be contextualized and in many cases transformed in order to realize meaning about the critical quality attribute. And that as being focused on multivariate sensors for real-time sampling and controlling, the first 2022 goals were really focused on developing appropriate platforms for the specific topic of glycan measurements, and most especially enabling real-time detection and accurate measurement for these critical quality attributes, utilizing inline sampling and preparation approaches, and identifying the appropriate equipment systems, supporting instantiation of a platform in order to implement these advanced analytics to realize value for other programs, most notably the adaptive control program. The 2022 goals will continue to focus on realizing the critical quality attribute measurements by supporting the qualification and implementation of all of the advanced analytical equipment that has been implemented at our test bed at the BTEC facility in NC State, but also to continue to support work that's ongoing with the data ontology work that you'll hear about in a moment, in order to ensure that appropriate contextualization of analytic information is embodied within the data contextualization and standardization. Additionally, the team will be working to identify its next generation of, or its next focus elements for data transformation and multivariate sensors, working with, as asked earlier, some of the other programs within Nimble to identify technologies that have the greatest value for realization across modalities and across the industry and the ecosystem at large, and also to identify opportunities to really focus on models and data transformation approaches to extract meaning about attributes from raw signals. The third work stream is the standardization contextualization, which is really focused on data storage and agnostic platforms that could be and include cloud-based storage to establish data storage and exchange standards that have applicability across the full spectrum from raw materials through manufacturing and quality analysis. The 2022 goals have been focused on developing ontologies, most especially for the upstream processing within bioreactors and the early stages of post-processing through harvest and protein A, capture chromatography. And we've been developing these ontologies with a contracted expert in order to develop the ontologies that are appropriate and have extensibility across the whole of the community. For those that are not familiar, ontologies are semantic information models, and that they provide the opportunity through creation to support extensive queries as well as natural language processing support that have very modern value in terms of instantiating data storage within cloud-based systems, but also to support its retrieval through different queries for modeling and monitoring purposes. In 2023 goals, we plan to continue to advance the maturation of these ontologies by self-developing them, having learned quite a bit, but also to really focus on driving towards open source software development, wherein the originating software ontologies that are created by Nimble that have more limited scope and uses are made available by open license so that the source code is then available to a community. And the community, utilizing guided principles with appropriate cadence of oversight and management, will, with trusted developers, have growing scopes and use cases of growing value and applicability to the biomanufacturing community and be matured through a community-funded platform that provides a trusted repository so that the code that's created would be secure and usable within the community and not put any kind of risk, but also provides the opportunity to verify the functionality of the ontologies within the community before they're ultimately released. And then upon release, to really drive adoption of the community of this valuable software. And in all of that, through the active ecosystem, to both provide information about performance and anything relating to failures so that we can improve, but also everything about performance reports so that we continue to improve and perfect the ontology for value for the biopharmaceutical community. The fourth work stream is focused on bioprocess modeling and simulation. And in this case, most especially to develop models that are appropriate for both physics-based modeling and for machine learning. We have three different models that we're advancing. One focused on cell culture, the second focused on depth filtration, and the last on proteinochromatography. These models in the 2022 phase are being developed with physics-based principles, solving partial differential equations, utilizing standard and established platforms for calculations, all very rigid and very modern models in order to provide very accurate predictions within these domain scopes. But I think, as many people are familiar, there aren't robust equations for any and all factors that influence these phenomena. So within 2023, we will be embarking on the hybrid model architecture, wherein we develop machine learning models in order to provide predictions, again, for things that don't have standard equations. And with the hybrid model architecture, join the machine learning models with the physics-based models, and the benefit of that overall structure being both the flexibility of the machine learning model to deal with a variety of inputs and factors and features that aren't easily dealt with standard physics-based equations, but to also ensure that predictions are constrained by the physics-based model to be realistic. I think you can see the synergistic opportunities between this development of these advanced models, which are data-driven, with the initiatives to create privacy-preserving computing and collect data from across the ecosystem in order to mature the models and ensure growing value. The last of our work streams are focused on real-time control of critical quality attributes and utilizing that control to ensure that we have robust control for critical quality attributes in the face of unexpected disturbances. A particular focus in 2022 has been focused on developing capabilities for critical quality attributes focused on glycosylation. And developing systems that can deal with exogenous variations, for instance, variations in raw materials and media that are otherwise disturbances that the control models may not appropriately account for. In order to advance that initiative, we have been developing a platform at NC State within the BTech facility and implementing many advanced pieces of equipment in order to ensure that we have process implementations that are industrial appropriate in terms of equipment and process parameters, cell lines, and media, but also implementing the control architecture with advanced analytics that again originated from collaborations with the BD3 team that was focused on data transformation to identify the most appropriate advanced analytic platforms to extract meaning from signals in relation to glycosylation. In 2023, we'll continue to advance these goals by maturing the platforms for the implementation, the physical hardware at BTEC, as well as maturing the development of the process, which was originated from cell lines and media that came from the data creation team, BD4, and we will develop the control algorithms through data and models that were originally matured within the BD5 domain in order to then have appropriate contextual models that will include both physics-based and machine learning in order to control the glycosylation critical quality attributes in the face of intentional exogenous perturbations with, for instance, cell culture media attributes. The program for BD4, as I mentioned in the BD program, as I mentioned in the beginning of this webinar, was launched with 2-year charters. And you see from this diagram that, back to the origination and thereabouts 2021, where we developed the scopes and the details. We identified appropriate partners and initiated contracts. And I think you can see that we've continued to advance ourselves well in terms of our overall goals. You can see that the goals for all the different work streams, they have alignment with one another. For instance, the creation of the cell lines and the media, and how that then feeds into develop of processes for the adaptive control. And how those processes then are utilized with the high throughput data creation systems in order to create data to support the development of models and the maturation of machine learning models to create the adaptive control demonstration ultimately at BTEC. We are now about halfway through that 2-year original objectives. We have a very important year ahead of us in 2023. In order to, as mentioned before, mature the platforms, the process, develop the algorithms for the adaptive control, which include the advanced machine learning elements, so that we have a very busy year ahead of us. But I think you can also see that we have a need to convene industry and academic SME again, to re-envision the BD program and develop objectives for a longer time horizon. We have really successful launch and start, but we really need to ensure that all of the work that we continue to do really has provenance and value for a longer term, as big data is really a critical enabler for the biopharmaceutical community in order to deliver drugs for patients. The potential program space really is quite large. If you look again across the landscape of our program, which ranges from data creation to control from data, those are, in the programs that I've been mentioning, they're very well aligned with manufacturing 4.0 technologies and a variety of initiatives that are occurring within other consortia as well as within the industry at large to utilize and mature tools in cybersecurity, Internet of Things, cloud computing, AI, machine learning, digital twins, and robotics in order to realize value in manufacturing. We're very aligned with a lot of the manufacturing technologies that are being advanced. But I think you can see our first projects really, they're focused on process design and technology transfer domain scope within biomanufacturing. And there's really a lot more associated with manufacturing. Clearly manufacturing operations, where drugs are made on the manufacturing floor, the quality operations, where all of the manufacturing process steps and actions as well as final product are assessed in order to assure that they meet the quality standards and compliance obligations. Facilities and engineering, which are critical to ensure that the space as well as all the equipment that are used for processing are in a fit for purpose state and ensure that we have the appropriate containment to ensure safety and security of medicines, and then ultimately supply chain. And I think everyone's familiar with the supply chain and the critical role that it plays in sustainability of manufacturing. We were all reminded by that with COVID, and we continue to have reverberating impacts associated with supply chain. So there's clearly a lot of opportunity for other projects across this larger domain. Examples of that are in some sense, common advancements that industry is implementing and are aligned pretty well with what it is that we've been doing within the Nimble Big Data program already. Is our programs are focused on yield improvement. Clearly, you can utilize models to, as well as control architectures in order to optimize the process to improve the yield. But you can do that across a broader space, not just within the process design, but you can utilize advanced models in the manufacturing floor, as well as within the quality oversight, et cetera, in order to improve speed, efficiency, and quality. And of course, models can really, within manufacturing operations, help dramatically in terms of providing improved real-time processing for demand forecasting, production planning, and system optimization. So there's really a lot of opportunity. And these are initiatives that they're maturing in a lot of different industries today, and there's a lot of opportunities within biomanufacturing as well. There's others that are emerging as well. Automated quality for monitoring with robotics and Internet of Things, predictive maintenance for equipment to ensure that all the equipment is in a state of readiness and fit for use, but not having excess spare parts or not shutting down the plant for preemptive maintenance when equipment is all in a good state of repair. Similarly, supply chain management, we all learned about that from COVID, and the principles of utilizing data to provide enhanced risk management and monitor product as well as supply chain, utilizing advanced monitoring techniques and devices, et cetera. There's clearly opportunities there. And there's additional opportunities that are emerging, utilizing data to have a better understanding of environmental impact, to ensure sustainability, to ensure that biomanufacturing continues to be a good partner within the world community in terms of the effluents from factories, but also minimizing the demand in the utilization of any type of raw material that might have detrimental impact across its full life cycle. The opportunities for wearable technology within the factory floor to really provide opportunities for greater insight, as well as virtual assistants to help manufacturing operators with their enhanced awareness, as well as to provide opportunities for enhanced training to ensure that all operators are familiar with changes to the system as well as the current operating standards. So there's really a lot of opportunity that are well aligned with our existing program and span across a larger domain space. And so in order to really implement these opportunities, we need to identify them and we need to determine which ones are really most appropriate with the overall landscape of Nimble, as well as which ones really provide the greatest value for members in the biomanufacturing community. So to that end, we are hosting a Re-Envision Workshop, and we will again be including expertise from all of biomanufacturing domains to ensure that we do have representatives from quality, manufacturing, oversight, supply chain, get the right voices into the room so that we can fully understand what the opportunities are, bring subject matter experts from industry, government, and academia that are not just familiar with the problem, but they're familiar with different potential solutions that utilize advanced data and advanced data capabilities. To do that, we're going to be hosting a hybrid meeting. We'll have an in-person opportunity for people that can travel to the Nimble headquarters in University of Delaware, but we'll also have a virtual linkage to ensure that we have a broad inclusion across the whole of the ecosystem. And that interactive teleconference will ensure that we have good participation and good involvement from all people that are engaged with the workshop. We plan on doing this across 2 different days, 2 different phases. And the first day, we'll develop the vision, mission, and objectives for a longer time horizon. And in this context, we're going to ensure that the workshop is open to nimble members and non-members. This is the whole biomanufacturing community, all of you. And it provides the opportunity to ensure that we really have a broad collection of voices to ensure that we're getting all of the right information to identify what really are the best opportunities for us to continue to advance the program to realize value for the whole of industry and members. And then our second day will be to focus on developing a roadmap for the prioritized objectives. This second day will be exclusive to the nimble members, but not those that are current participants within the BD program, for instance, but all nimble consortium members. And that, again, ensures that we have a broad voice, that we have a lot of expertise, and so that we can realize both extension of all of the benefits and technologies that we've advanced already. So we have strong continuity with our past work, but also to ensure that as we develop the roadmap, as was mentioned in the question before, that our maturation is coincident and synergistic with other programs that are going on within NIMBLE, as well as other programs that are going on within the industry at large. So really our intention with the whole Re-Envision Workshop is to develop a longer term horizon where we can go from today, where we have big data that emanates from biomanufacturing, in some sense silos within different companies and different companies that are at different state of maturity in utilizing that data, but to develop tools that provides for data enhanced advanced manufacturing, providing consequent quality efficiencies, as well as economic improvements, which are beneficial to all, and with further time and further investment to ultimately achieve next generation biomanufacturing, which really provides the opportunity for new drugs, a new speed, and great value to all. So this workshop is really a part of a continuing improvement strategy that we have within the Big Data program, where we intend to ensure that we can transition in the face of change, we can sustain our continuous improvements, and we can sustain the technologies improvements and adoptions to evolve in the face of change as new technologies emerge and new opportunities to engage with other partners become available, and then ultimately to involve a increasingly large segments of biomanufacturing industry experts, subject matter experts. So we really seek to continue to improve. And with that, I thank you for your time, and I'm happy to answer any questions you might have.
Thank you, Roger. We do have a few questions ready to go, but I'd like to remind everybody that please ask your questions in the Q&A or put it in the chat if you want. But the Q&A can be accessed through the by clicking on the three dots down in the lower right-hand corner of your screen. So please do ask the questions. So Roger, one question came in. It says, is there any advantage in ETL or extract transform load over ELT, extract load transform approaches to for an agnostic approach?
Well, I'm sure that's a great question, but I'm just not familiar with those acronyms in a way that I can provide a meaningful answer. Maybe the person that asked the question could provide a little bit of clarity to you, and we can come back to that question.
Okay, great. Okay, so how are the ontologies vetted through industry, and are they aligned with regulatory initiatives, if appropriate and relevant?
That's a really great question. So that's among the biggest motives for going open source with the development of the ontology, to ensure that we have the full community that's participating, sharing appropriate vocabulary, really contextualizing the meaning in terms of the overall relationships of concepts, and including within that participants from regulatory agencies and the like. At present, in order to ensure that we were advancing successfully and really value to members, we have more limited use cases. We're focused on monitoring and contextualization data across the span from raw materials into process and in process performance. And we're doing that most predominantly for a limited segment of process ranging from cell culture through primary purification. And that's an intentional limit of use case scope to ensure that we have a strong foundation for development and that the fundamental tools that we're building upon, such as IS-88 and the like, provide a strong and sensible foundation. But per the question, yes, the adoption of ontology, well, for me, I liken ontology to simple vocabulary and language. And I would ask everyone, what's the utility of a language that only you know? Languages are appropriate for communication. So if we're all speaking the same language, then clearly there's greater value that's realized from that. So the opportunity to be able to create an open source ontology effort where all of the members of the community are all participating to create that shared instantiation, that shared understanding of what things mean and associate that meaning with the underlying data. The benefit is to all if all are included. So that's the real initiative. My best response to the question is, come join us. That's the way that we ensure that everybody's involved. Thank you.
Great. Thank you, Roger. We have a few more questions. Let's start with the easier one first. So when is the BD Re-Envision Workshop?
Thank you. Someone who wants to join us. Thank you. I'm excited about that. We're planning the workshop for March of 2023. The specific dates we're still, nailing down in terms of the availability of the facilities and the like. But yes, please think of March 2023. So that's not very far away. We have a lot of work to do before then. But the availability of both the in-person as well as the virtual is going to be really key. So we want to be able to have a way to host innumerable participants utilizing both the virtual and the in-person. So if you have interest in the workshop, please share that truth within the chat. Make sure that we're aware of your interest so that we can direct information to you for your participation. Thanks for the question.
Great. So the next one is, how are you going to assess each step of the program? What are the success criteria for each component of the program?
Oh, that's a truly excellent question. Thank you. So within Nimble, we can control the delivery of valuable things. Right? So we intend to deliver ontology that has been tested and is available. We intend to deliver control algorithms that are available and are tested. We intend to deliver models, right? So delivery of a valuable thing that works, that's something that we can test, right? That we can ensure. The next stage is adoption and implementation within industry. And we need participation and collaboration for that to occur, right? Understanding the implementation of the tools, where they have worked well, where it is that they could be further improved. So the whole of success really depends on the community as a whole. And so we really seek, again, through privacy preserving and other, trusted approaches, to provide opportunities for, very honest feedback in relation to how the different assets that we create are performing, how it is that they can be improved, what type of transformation they're actually producing out in the real world, because that's really the intention, right, is to improve the effectiveness of biomanufacturing for delivery of medicines for patients. I hope that answered the question.
Great. Thank you. So we have time for a couple more questions. One question that came in is, what kind of SME requirements are you looking for the skill set to participate in the big data program or big data Re-Envision workshop?
Oh, well, wow, that's great. Great question. So, it really does range from, practical experience across those domains that are listed, especially the practical experience entailing knowing what the problems are, right? So that the current state, this is what we do, is understood, right? But also, what are the problems with what we do? What are the impediments? What are the bottlenecks, right? What are the problems that need to be solved across these various domains? That comes from experts knowing manufacturing, experts knowing quality, experts knowing supply chain and inventory management. But we also have a need for advanced data scientists that know what type of opportunities for solutions there's interest in within industry, right? So we can help to ensure that the technologies and the projects that we embark on really are appropriate, that the type of technologies in terms of their pervasiveness, their security, their reliability, et cetera, is all appropriate for the end users in mind. So definitely we want data science experts and the like. So, in general, it spans from subject matter experts across the various domains listed, as well as, scientists, data scientists, and kind of advanced practitioners within science that have identified ways to create improvements. And in general, I'm of the view that some of the very best ideas come from people that are just entirely outside in virgin territory. There are technologies that are being implemented in other industries that are significantly further ahead than biomanufacturing. Biomanufacturing has a variety of different reasons for why it is that it's, if you will, not leading the curve in terms of implementation of manufacturing 4.0 technologies. But still, there's a lot that we can be learned from implementation in other industries. And so there really are experts from industry and as well as academia and government from adjacent domains, right, that have understanding of manufacturing 4.0 tools, how it is that they can be used across the full supply chain in order to realize value, and how conversations with those, call it big data experts, when joined with biomanufacturing subject matter experts, they can have meaningful conversations to translate appropriate solutions from other manufacturing domains to the biomanufacturing domains. So I would say that the most critical skill set is enthusiasm and knowledge, right? People that really want to see change and have both experience and understanding, as well as imaginative ideas for how it is that we can be dramatically different. Thank you for that great question.
Thank you, Roger. So can you elaborate a bit more on your future vision for the big data program and how you foresee it being implemented industry-wide?
Oh, that's great. Thank you. Yeah, we could talk about this for hours and hours now. The end result, the end success, is adoption and implementation within industry. That's it, right? Medicine is made by biomanufacturing companies. That's where we want to change, right? We want to change to impact patients' availability of medicines, the strength and stability of the companies that make medicines for patients, the full science production life chain, right? So adoption of technologies is critical. There's a variety of different impediments that are practical for that implementation, some of which are, pertain to risk or perceived risk. Sometimes it's simply a matter of identifying what those perceived risks are, and there can be relatively, modest solutions that can be implemented in order to address those risks. But the key first step is to really recognize that implementation in industry is the ultimate goal, and that's where the value is realized. So understanding, what is the path to adoption? What are the impediments to adoption through honest conversations with members in industry as a whole to ensure that the technologies that we're investing in they're not just shiny nickels, right? These are technologies and tools that industry needs, that an industry wants to implement. And industry is happy to be partners, right, in both the development and the implementation and adoption of the technology. So ultimately, success really comes from the community, right? For me, success is adoption in industry and implementation in industry. And clearly, that's a longer term goal, right? We can develop individual projects and develop assets and make them available to our partners in a year's time. But it might take more years in order to really realize value within industry through application of those tools. But the more we understand where those tools are being applied, and the more we understand the challenges that are encountered in applying them, so that we can overcome those challenges to support industry to implement and adopt, that's where we all win. I hope that elaboration helped with understanding the overall life cycle. If there was one last thing that I would add to that is that I love standing on the shoulders of giants. You can see much farther. Thank you for that wonderful quote from Giants, right? So in that context, industry as a whole, within manufacturing 4.0 principles, right, and advanced technologies, there's a lot that are being implemented in other manufacturing domains. There's tremendous opportunity for us to identify some of those successful technologies and adopt them within biomanufacturing and identify what are the appropriate transformations or adjustments of those technologies to ensure that they're successful within the compliant and more constrained manufacturing domain of biomanufacturing. But that there really is great opportunity for us to exploit the advances that have occurred within other industries and transform those technologies for implementation in biomanufacturing. Thank you so much for the question.
Yes, thank you. So we got a couple more questions in. Is Nimble building its own framework of capable IT tools, or using off-the-shelf IT tools and modifying them where necessary?
Oh, that's a great question. Well, Nimble has secure servers that are located on the University of Delaware campus. That there's quite a good, very strong and secure network in that context. We also have access to other quite secure networks from our partner universities, et cetera. We do work with different contracted, both commercial and or academic developers to develop models and other IS assets. And we ensure as we create those that we keep them in secure environments so that ultimately those valuable assets can be delivered to members in a low risk context. But we also are key, given that we're really driven by adoption, to ensure that technologies that we're working on, that they're also mature enough in their own life cycle, right? That it's not just starting with purely developmental concepts, but that many of the technologies are either already commercial or they can be made commercial. So we do like to work with partners that do have some degree of experience and some degree of maturity in amongst that implementation. And clearly that does involve, for instance, existing commercial controlled systems. But there's also great opportunities for technologies that are a little more emerging and that they're strong, but they really need to develop, if you will, their implementation and customer base. And it's through opportunities, a partnership with collections of people where their tools can be matured and they can also demonstrate their value. And of course, you can see open source is a great opportunity for the big data program. because of the opportunity to really collectively develop assets that are valuable to everybody because everybody helped develop it. And that helps to really lower the barrier for adoption because people made it what they wanted it to be, right? In order to do that successfully, we're clearly going to be working with sound partners, utilizing secure approaches so that the software assets are residing on platforms and that there's an overall management structure to ensure that any type of revisions and modifications to the overall underlying code are appropriate and that they're functional and that they're safe and secure. That you can see that that's a universe of different participants. It's not it lies in general in the middle space, right? Of technologies that are maturing, but they really need additional support for their maturation and global adoption. Thanks for the question.
Okay, thank you. So we have about 2 more minutes for questions and answers. So maybe we can squeeze in 1 or 2 more quick ones. As a Nimble member, how can we access the data?
How can you access the data? Well, the Nimble big data projects and their deliverables, they're available to Nimble members that have access to the Nimble work streams owing to their membership and their level of membership. That's a practical membership access matter, right? To ensure that there's value realization in association with membership. Different opportunities, however, for sharing in larger communities, say, for instance, with the ontology and the opportunity to open source. Those now provide opportunities for, if you will, larger audiences, larger access. So, in general, to have access to the data and the assets that are created by the Nimble Big Data Program, you need to have access to the Nimble Big Data Program and/or work streams through your membership. But please participate with us with the workshop. Help us to identify where it is that there are opportunities for us to create data sets, maybe mature them in a little bit more of an open community, so that where there's opportunities to create greater value and create greater adoption by ensuring that we have a larger access and larger community, that those appropriate opportunities can be identified.
Great. Thank you, Roger. I think that's about all the time we have for questions and answers. We have a couple closing slides here. So again, we'd like to thank everybody for attending the webinar and participating in the question and answers. We appreciate everybody's feedback. So in closing, I'd like to remind everybody that there will be a survey coming out after the webinar is complete. And by completing the survey, you will get immediate access to the webinar recording, which you can share freely because it's public. Again, we'd like to re-emphasize that there is a few more webinars coming up. And you can see the dates here below for viral vectors, NMAB, and BRL. And you can register at the nimble.org website. So can you advance? Thank you. And to get information on the big data program, as well as all of our Nimble projects, you can always go to the Nimble website. And if you're a member, you can go through and follow anything that you're interested in. You can see the follow button on the right-hand side here. And that would give you, that would send automatic emails when there's updates, and but it won't come out any more than once a week, so you don't have to worry about filling up your inbox with Nimble updates. So I think can you go to the next slide, Roger? That might be it. So again, thank you everybody for participating in the Big Data webinar. Have a great day.